Welcome back to section 8.3. We just finished talking about absolute value equations. Now I'd like to transition into absolute value inequalities. So we talked about the equations. So like if you have the absolute value of x equals 4, you've got two options. X could either be 4 or negative 4. But let's talk about those inequalities. What if the absolute value of x is greater than 4? So the distance from 0 is more than 4. Well, it could either be more than 4, x could be greater than 4, 4 or 5 or 6 or 7, or x could be less than negative 4. It could be negative 4, negative 5, negative 6, negative 7. It could be those larger negative numbers to have a bigger absolute value. What about absolute value of x is less than 4? Well, those are smaller values. Those are things that have a smaller distance from 0 on the number line. So you could either have x is less than 4, and it's also going to be greater than negative 4. So it's going to be between negative 4 and 4 on the number line. So we're looking at negative 3, negative 2, negative 1, 0, 1, 2, 3. Those kind of values that have small absolute values. Okay? So what I notice with these is that one of them always looks the same as the original, but just without the absolute values. We have x is greater than 4 or x is less than 4. It was exactly the same sign as the original. And then we can switch the sign and flip the sign over here to have the other option. So it's always, one is greater, one's less than, or one's less than, the other one's greater than. And that switch always happens with the negatives, okay? With the or and the and, I always remember that great or than has the or, if that helps you at all. Great or than has the or. And then with the less than, in my brain, I think less than has an and, if that helps your brain at all. Remember the ors and the ands. So let's get going. Let's do some examples, okay? Oops, not that many examples. Here we go. So example 4. What I have for us is the absolute value of negative 3 plus t is greater than 8. Okay, so if it's greater than 8, what I'm going to have is one that looks a lot like the original, but just without the absolute value. Negative 3 plus t is greater than 8. Or, because it's greater than, I'm going to have negative 3 plus t, and then I'm going to switch the sign and switch the sign. So switch and flip. So I'll flip to less than and switch to negative 8. That's what the other one looks like, okay? Now that we have those two together, let's go ahead and solve each one independently. We'll graph them and we'll figure out where that union is since it's an or inequality. So to solve the first one, I would just add 3 to both sides. So I've got t is greater than 11, or on the other one, we'll also add 3 to both sides. So now t is less than negative 8 plus 3, which is negative 5. Okay? So let's go ahead and graph those on the number line. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is way over here. X is greater than 11 would have a parenthesis, and it would go to the right. T is less than negative 5, so negative 1, 2, 3, 4, negative 5 is over here. Less than negative 5 would have a parenthesis, and it would go to the left. All right. If we were doing an and inequality, this would be no solution. But we're not doing an and inequality, we're doing or. So or is where either one of those sets is part of our answer. Basically, we're smushing them together. We're saying both of these together are the answer, are the solution to this inequality. So we will have two pieces though. So on the first piece, how far left does it go? It keeps going forever in the negative direction. So that's negative infinity. How far right does it go? It stops at negative 5. We'll have a parenthesis for the infinity. We'll have a parenthesis for the 5. Then we kind of jump over here. The second part of our graph, we start at 11, and we keep going forever to the right, so that would be an infinity. We have a parenthesis at 11. We'll have a parenthesis with the infinity, and then we join those two together with the union symbol. So that's what our graph looks like, and that's what our interval notation looks like for this one. All right, Example 5. Next one we're going to do has the absolute value of 3x plus 2 plus 4 is less than or equal to 15. So the first thing I need to do is get the absolute value by itself. I can't split it up until it's by itself. So I'm going to subtract 4 from both sides. Get the absolute value of 3x plus 2 is less than or equal to 11. Now that the absolute value is by itself, then I can split it apart into my two inequalities. So I'll have 3x plus 2 is less than or equal to 11. It looks like the original, but just without the absolute values. It is less than, so we're going to use an and, less than. And then the other one is at 3x plus 2, and then we're going to switch to negative 11, and we'll flip our sign to be greater than or equal to. Okay, that's what those two different ones look like. So I'm going to solve each one by themselves. We'll graph them, and we'll find the intersection. Okay? So from here, I'll subtract 2 from both sides, so 3x is less than or equal to 9. I'll divide both sides by 3, so I get x is less than or equal to 3. On the other one, I will also subtract 2 from both sides, so now I've got 3x is greater than or equal to negative 13. And then I'll divide both sides by 3, so I get x is greater than or equal to negative 13 thirds. Well, I'm about to graph this on the number line. I'd like to know where that is. So I'm going to convert that to a mixed number. 3 goes into 13 4 times. 4 times 3 is 12. 12 is, has a difference of 1 from 13. So it's 4 and a third. It's still negative. Okay, and we have an and inequality. All right, let's graph each one separately. Then we'll find our intersection. So on my number line, x is less than or equal to 3. Here's 0, 1, 2, 3. It's going to have a bracket at 3 because of the or equal to, and it's going to go to the left because of it being less than. Okay. X is greater than or equal to negative 4 and a third. So here's negative 1, 2, 3. Here's negative 4, and there's negative 5. So negative 4 and a third is just about here. Okay. It's a little towards the negative 4, but it's between negative 4 and negative 5. We will also have a bracket because of that or equal to, but this one will go to the right. Okay. So with that and inequality, you're looking at the intersection. You're looking at the overlap between the two graphs. So where do they overlap? They overlap right here between negative 4 and a third and 3. So when I'm doing the interval notation of that overlap, how far left does it go? It starts at negative 4 and a third. It does have a bracket because we are including it, just like in the graph. How far right does it go? It stops at 3, and 3 will also have a bracket, okay, because they both were or equal to, and I even included that in my graph here, so I remembered to use a bracket in my interval notation. So there's the graph, there's the interval notation for this one. Okay, now it's your turn. You all get to try one and show me how much you've learned.